Hey guys, how we doing? Doing some work on a 79 VW Westy camper, and some welding in the back. It has an issue with overheating in the summertime when it's sitting in traffic. I'll show you what the issue is with that. The way VWs work, I should back up, is they're air cooled. Air comes in through vents somewhere on the side of the vehicle, whether it be bug louvers on the back of the engine lid or above it. On buses, they have them on the side there, or on the earlier ones. You can kind of see them on the side there. The idea is for the cool air to come in there. Actually, you get kind of a ram effect when you're driving. It comes down to the engine compartment. There's a big fan on the motors. Here it is on this is a 2-liter type setup. Air gets sucked in through here and is blown down across the cylinder heads on tins and exits out the bottom, and part of it blows up through the heat channels. Well, on this one, it was had a big hole in the side right here, and the hole was a where an AC compressor was. And I think this van originally had AC. I'm not sure what the reason is why it was taken out or what the deal was, but they kind of hacked a hole into this corner and tried to kind of seal it up with some flashing. This was just kind of stuffed in that corner and screwed down into place. But that was a temporary fix for the owner after they had a motor put in. And he had a tin on here. Where is it? And this is what was left of the tin that goes on it right there. So I actually met him at a swap meet. At the time they were picking up a new tin, which they did, which is this one right here. So I got that one just kind of sitting in there for mock-up. And then they hacked this corner was hacked out of here. So that's what they had bridging across, was that piece of metal. So I spent a couple hours yesterday just kind of cleaning it up and getting us something to work with. I got a little bit more grinding to do down there. But then I had to kind of make this compound piece here for filling that gap back in, and it needs to get welded back in. What I do is I made this piece first out of cardboard, and then I laid another piece on top of it and traced it, then trimmed it back. So that piece is going to be going in there like that. And then if you notice, you got like that 1-inch gap going around everywhere. Something like that. You'll see that it's got roughly about a 1-inch gap or a 3/4-inch gap kind of going all the way around in the track there. And again, what it's doing is the exhaust is right below it, and it's allowing it to suck that hot air right up, right into the fan. So basically that's where the airflow is going instead of from the other way. So you just keep regenerating that same area. So after I get that squared away, there's a seal that goes in between them. I just took it out of the box, try to get it to relax, going back to position. Basically it just looks like a big H. And that will seal off those two areas, because that motor still wants to rock in there a little bit. It's on motor mount, so you need something that's flexible. But this is more about I guess we can call it like tips and tricks for welding. Some of the guys are watching do weld. Not a professional welder. I've done a lot of welding. I got a bunch of welders, so I'm just going to try to throw some stuff out there that works for me. If it works for you, fine. If not, sorry. Some of the guys are using flux core wire, and I'm going to talk about the difference between the two of them to begin with. Flux core wire is a wire that is actually hollow in the center. If you were able to blow that up where's the eyeball? You were able to blow up that tip of that real good, you'd actually see, we'll give this, actually this whole thing as a demo. Pretend this is a cross-section of the wire. The actual wire is hollow in the center of it. There's actually, the center of the wire is actually filled with a flux, just like it says. That's why it's flux core wire. Inherent problems of flux core wire is that it's just a larger wire in general. This is 035, and you could actually get it in 030, but just the size of it alone makes it hard to weld thinner material. And most of the time when you go with a thinner material, you're going to try using a thinner wire. Like this is a solid core wire, and it's 024. They go anywhere from like 023 to 025. I think it's all the same stuff. Anyway, there should be a bit of this wire sticking out somewhere. You can use. I thought I saw some earlier. Oh, there it is right there. So if you could see, my lighting sucks, the thickness difference between that guy and that guy. That's what you're dealing with. I use Flux core for a lot of things. It's good for crappy material, which is 90% of the stuff that I'm working with. If you're working with really nice clean metal and put new parts together, this with gas works very well. This works very good for doing nasty crappy stuff and stuff that you're cleaning up and just repurposing metal. And in my opinion, it's cheaper in the long run. You're not running the gas bottle, and it makes the welder much more portable. I have two setups. They're both 220 volt welders on the smaller side. I think they max out at well, the Lincoln's a 175. I think this is about the same thing. This is a Miller sold for auto body work, but running the same idea, probably about 175, 185 is the output of this one. Does it even say? Not sure. But they both have the same idea. They got 4 different heat range settings, and then the variable as far as your wire feed. And one thing I want to talk about with the Flux core wire is that you have 2 different polarities on your welder. Being you could have the electrode hot, or you could have the ground hot. You can flip them around, and it matters what you're welding with. If you got fixed solid wire, rather, you're just going to go with DC straight, and then you got to reverse the polarity if you're using a flux core wire. If you don't, it just gives you really weird inherent kind of welds. It'll kind of try and weld, but it's trying to weld the wrong way. It's trying to put the weld on the wire almost. And if you can see right here on mine, you can change the polarities with these guys right here. As far as let's see what I want to talk about next. For me, kind of one thing I want to go back on. If you look at the chart, it'll kind of give you an idea of what you're able to weld with what wire. So if you notice the stuff like in the 024 range, 24 gauge rather, and 2220, this is the thin stuff that most of your auto body panels are made out of. It's pretty much saying that you're going to go with an 025, 024, 23 size solid wire with gas, and you'll be able to get down. It's telling you what the settings are too. Heat range of A and a speed of 2. It's kind of what you're going with, and when it starts getting in 20 gauge, it goes a little thicker. You got to remember that it's the same amount of material. So if you're running the thin wire, which is this wire up here, compared to the flux core wire, which is this wire here, you notice that it's running, you have to put more wire out. You see that you're up at 3, up here B and 3, and like here you're at A at 1.5. That's because the wire is thicker, so you need a slower speed. That makes sense to you? So thinner wire, you got to turn your speed up. Thicker wire, you got to turn your speed down. I actually kind of run them a little bit on the hotter side, but what I do is I don't try and run. Let's see if I could do this one-handed. I also keep a block of metal on my bench just for tuning up the welder. You can see this is just a hodgepodge of just absolute crap, but it's just for firing up different welders. Instead of welding and trying to get your weld going and try to run a whole bead, especially with flux core and running the thicker wire. This is on thin metal, by the way. I like to hit it, buzz it for about 5 seconds, stop. And I let the red puddle kind of glow down a little bit. I watch the puddle. I'm using that puddle to tell me what is going on. You're worried about blowing through. Get a piece of scrap of the same material that you're working on, and then just try to see how long you can weld for before you blow through, and count. Say like you count 1, 2, 3, and you blow through. Okay, so you know at the count of 3, with the speed that you were moving, you're going to go blow through. So you can just go 1, 2, stop. Let the puddle kind of glow. They go down a little bit. You'll watch the puddle. 1, 2, stop. You could do that all the way through, especially with thin stuff, and that's how you can use a flux core on that thinner wire. If you try just holding the trigger, you're just going to blow through. You're going to blow through like crazy. I mean, there's tricks a lot of guys talk about. You can put brass or copper or aluminum behind it, and use that as a backing for the thin material so you don't blow through. But a lot of times you don't have that capacity to do that. One of the other things too, the guys are doing spot welds. One of the last videos I saw, and say if you're doing a plug weld rather, and you have your hole drilled out and you're trying to weld the material underneath it. If you go with too small of a hole, the metal underneath does not get enough time to get hot to flow into the center, and that's what you're trying to do. You're trying to get that puddle, you're trying to get the metal underneath it to wetten up in a puddle, and then you're going to try drawing that to the outer weld. If you have too small of a hole in the center, it just kind of plugs that area up real fast. Now you're melting out here and you're not getting to that metal that's underneath it. And again, the same thing with the flux core wire. You can just go bzzz, stop. Let the puddle kind of glow down a little bit. Bzzz, stop. That's why I like to run it a little bit on the hotter side. I actually get the material to flow down into it and then stop. A couple things about the flux core also that I like. One is you don't have to run a tip on it. The shielding gas is created for when the wire gets heated up and it burns that flux off. Kind of the same idea as soldering, or actually arc welding, the same idea. So you could actually see what you're doing with your gun a lot better than when it's covered up with a tip. You can actually see your puddle really good. And I like to keep about, that's probably about right there. Maybe a little shy of that as far as your stick out. Probably about a half inch, yeah, half inch. We'll stick with that. And that gives it a good ability to see what you got going on, especially like on this bus right here. It's a very tight area to go weld that in. If you're using a flux core, see it again. If you're using a solid gun, you can see that it's a little harder to see, a little hard to get in there because of the shield that's or diffuser that the gas is kind of circulating around and giving you a clean weld area. The idea of the welding gas is to get oxygen out of your area because that contaminates the weld. So when you're running a bottle, the gas comes out all the way around the tip, and if you try welding like this, like with the other welder, it's not going to work very well just because your gas is not keeping the area purged of oxygen. So the flux core gives you that capacity. You can weld on an angle. You know, you could actually even just feed it, you know, 3/4 or an inch away if you can't reach that far. So that's the benefits of that. Anything else to talk about? I like to keep, again, like I said, a piece of scrap on the bench, and just to play with your welders. If you have like whatever you're welding with, if it's 20 gauge, 22 gauge, really thin stuff, practice on that stuff too, and just kind of fine tune your welder and get an idea of what it's going to do with the wire that you're running and how much it's putting out. So anyway, that's why that pile of crap is that you can see with you know, if like you turn it up all the way, you'll blow right through. Yep, that was done with a. I think I did that with one of the welders. I turned all the way up. I just wanted to see what it'd do, and it would just cut right through it. Welding helmets. I got another one that's in my truck right now. I'm doing some welding off-site. This is a yard sale welding helmet. It's actually a fairly decent one. Auto darkening. If you can get an auto darkening helmet, even the Harbor Freight ones, they will make you a much better welder, because the fact is you could just see what's going on through the lens when you're not welding. On a regular welding helmet, it's just so dark you can't tell where you are. You can't. I mean, a lot of times you're just kind of like lighting up the area just so you can kind of get a picture of where you need to start your weld. So auto darkening helmets are kind of a must, and they're fairly cheap now. I said the Harbor Freight ones are fairly cheap, and I just want to talk about one thing with them. With the cheaper welding helmets, there's another one up here. The cheaper welding helmets, the way they work is soon as they see a flash of weld, then they respond to it. But there's a reaction rate, how fast they operate. A good welding helmet will have a very quick response to the arc, so fast that, well, actually they're both so fast that you don't actually see the weld. Your eyes don't have time to react, but it just looks black to you when you start welding. But on a cheaper welding helmet, it's slower than it is with a good welding helmet, and it doesn't really bother you when you're just doing like a quick weld like this thing, you may be welding for 15-20 minutes. When it'll show up though is if you're doing a shitload of like little tacks and you're just tacking stuff together all over the place, and you're spending hours doing that, taking it apart, tacking it again, or doing little stitch welding a panel going down it. Over time what's going to happen is you're getting exposure to that, and you're going to get what's called Welders Flash. Basically it's like staring at the sun for too long, and your eyes in about, generally it's the next day, and you'll start feeling it, will get feel like you got sand in your eyes, and that's what's causing that. So if you're going to do a bunch of welding, you may want to step up to a better helmet, or just limit your exposure, how much you're doing it. I made that mistake a week or so ago. I brought my crappy helmet with me to a welding site, and I paid for it for a couple of days. So just another tidbit on that. Anything else I can offer? When you're using these smaller welders, like the 110 welders, I have 2 of them now. They're basically their output, depending on what you got, they kind of max out at about 135. But generally, the ones you're getting from Harbor Freight and all, they're like 90 is what they're putting out, and they're marginal at best. They're trying to get a puddle going, so that you'll find, especially with flux core, with gas, again, you're running a thinner wire. You don't need as much power to get that thin. Wrong one. To get that thin wire to do what you need to do, and if you're running the flux core, again, you're just at that marginal point of what the welder is able to do. So try with the slowest feed as you can, and use the vise as a work area. But when you're welding and you don't have that much power, try not to be moving around stitching so much, because then you'll feel the welder when it'll like, you'll be okay, and then all of a sudden the welder kind of pushes off a little bit, and it's pushing off a little bit. The problem is you're not keeping it in the puddle. You're working with such a tiny puddle that you just want to move that thing. I'm over exaggerating now just to show you, but just enough to kind of keep that going. Sometimes you can even just kind of pull it in a straight line, but keep your motion as shallow as possible. The more that you move it around, the more that you'll feel it kind of pushing off on you, and you're thinking that your wire speed is up too high. It's not your wire speed, it's just that you're working your way out of that wet molten puddle, and now you're trying to fight it. So just try and slow down a little bit and get used to it. Again, if it's going the other way where you're burning through, don't just stay there trying to weld and weld and weld and weld. Run it for a couple of seconds, stop, run it for a couple of seconds, stop. If you blow a hole, stop, let the glow go away on the hole, then you can come back, and wherever the biggest amount of material is, just hit it again right there, and you can just kind of work your hole closed. But just take your time and slow down, and let the orange glow go away before you hit the trigger again, and because you're going to heat the metal right back up again. Alright, I figured enough gabbing on this. I just wanted to give my 2 cents on some of the stuff that works for me, and hope it works for you. We can talk about cleansing this metal too. Depends on what you're using. There's different kinds of metal that you're doing body work with. I'm real bad with using just scraps or whatever I got. This is Galvy. This one's 16 gauge, that one's 18 gauge, but it's got a lot of shit on it. It's real hard to weld. It's not good for you. After I made those pieces, I threw them in the sandblaster. You can kind of see it there. It was in the sandblaster, but even after that, you can kind of see it's still got the Galvy on it until I ground it off. See what the grind marks are. So you gotta kind of have a clean material to work with. Again, flux core will be better with contaminated material than solid with gas, but you want to be aware of that. And then the other thing is there's a difference between hot rolled and cold rolled steel. Let me see if I can find you some in my scrap pile back here. I should have a lot of hot rolled. There we go. I worked at a metal fabrication shop for a while, and this is all just bits and pieces of stuff that are left over. Come on. It's gonna make me a liar, right? Alright. What's this? That's stainless. You got a piece actually right here. You look at this metal compared to this. Hot rolled has like a mill scale over it, and it kind of covers the whole thing. It actually will look like you got bare metal, but it's not. It's got that coating on it. You got to grind that off, and it will fight you pretty good. Let me see if you can see the edge of it, if you can see the color difference. Can you see how the edge is shinier where it was cut compared to the darker color that's on the front of it? Again, that's that from hot rolled steel. That's the process that's in there, and that will give you a cold weld also, because you think you're trying to penetrate onto something that's bare metal, but it's really not. You have that layer of slag, for lack of better terms. It's mill scale. So it's the shit that flows up to the top of the metal when it's cooling off. All right, guys, I'm not gonna make this video too long, but I figure we'll give her a shot. If you guys like this kind of stuff, just let me know. If you think it's, I don't know, too much information or whatever, just give me a shout out on that too, and I'll steer my videos towards that direction. And they're spawning. There's another one. I'll do a video on that later. Take care.